Time-appropriate greetings, everyone, and welcome back. In this video, we're going to use a seasonal forecasting model to make forecasts about book sales for a local bookstore. They've recorded book sales for each season in the years of 2016 through 2020. We're going to use an additive and a multiplicative seasonal model to forecast the book sales for each season of 2021. Using some logic, we're also going to think about which of these two is best suited for these data. Given the data, we should really plot the observed values on a scatter plot to observe if there is a seasonal trend going on. As you know, a seasonal forecasting model is only appropriate if you see a fixed pattern happening over and over some time interval. So let's select the observed time periods and sales here and insert a scatter plot. Up in the ribbon, hit the Insert tab, go to Recommended Charts, hit the scatter plots, and insert an XY scatter plot. What you see is that over time, the sales follow a very distinct pattern. They start here in the winter, they go down in spring, they go down even further in summer, and then they shoot back up in fall. And this pattern repeats year after year after year. Seeing this repeated pattern of period 4, because it's 4 seasons that happen to repeat themselves over and over and over again, that makes this a perfect candidate for a seasonal forecasting model. Let's move this out of the way and get on with our forecasting. To do a seasonal forecast, you need to know what the regression line is for the data that you've observed. So we'll find the slope of these data using the slope function. The y values are the sales. The x values are the t values. Remember, we're only finding the slope for the observed values. Slope is 20.99. So year after year, this pattern is moving up about 21 units per season, 21 extra books per season that we forecast. Season goes up, predicted sales goes up by 21 books. The intercept of this line is given by the intercept function. The y values are sales, the x values are the t's. The intercept is 68.18. So if you go back 1 month to fall 2015, I would predict 68.18 books for that month. Using the slope and intercept, I can now compute the fitted value, or the unadjusted forecast, for each season. We compute this by taking the slope, multiplying it by the season number, and adding the intercept. When I autofill this to the remaining seasons, I don't want the references to these to move, so we're going to want to fix their row numbers. So put a $sign in front of the 4 in B4 and put a $sign in front of the 5 in the intercepts B5. Hit enter and autofill this to all of the months. These are our unadjusted forecasts for each season using the regression line. That's the regression line that you could also stick on this chart. So these unadjusted values that we've computed in column E are the values along this regression line here. Sometimes the observed values are higher than the regression line, sometimes they're lower. We notice that fall always seems to be quite a bit higher than the regression line, and that summer always seems to be quite a bit below it. That's what we're going to adjust with these seasonal indices. The additive seasonal index is going to add a little bit in fall, subtract a little bit in summer. The multiplicative seasonal index is going to multiply it by some larger number in fall to boost it up, and some smaller fraction in summer to boost it down. Figuring out exactly what these are, let's compute the seasonal indices. In winter 2016, I observed 72.01 in sales and I predicted 68.38. In winter 2016, I actually saw 362 more books sold than I would have forecasted. We can autofill this down to the other observations. You'll see that negative values mean that we sold less than we would have thought. In summer, we only saw 5,600 when we forecasted 68.80. Gives us an additive seasonal index of negative 12.80. The question now is, how much do we need to adjust these fitted values for each of the seasons that we want to forecast? To calculate the seasonal index that we're going to use for winter to modify this fitted value, we're going to take the average of all the previous winters that we've observed. That's the average of the 362, the 284, the 204.44, the 125.50, and the 157.31. So we're going to take all of the average deviations for our winter sales. 226.74. So the average winter was 226 books more than I predicted with the regression line. And for spring, it's the same thing. We're just going to take the average of all the previous springs. This one was 404 less. This one was 343 less. This one was 484 less. This one was 607 less. And this one was 652 less. On average, our spring sales were 500 books less than we predicted. We could continue using the average function and clicking individually, but because all of the seasons are underneath each other, and they're all cascaded like this, we can actually just autofill this formula, and it will automatically move the references down for us. Here we see that fall is our best season. On average, we sell 1,600 more books than we thought we would. Summer's our worst month. We sell on average 1,300 books less than we expected to. The additive forecast can then be computed by taking the predicted value from the regression line and adding this adjustment. In winter, we on average saw 226 more books, so we're just going to add 226 to the fitted value, 7485. That's our adjusted and final additive forecast. We autofill this down and we get a forecast for each season. For fall, the line tells us 7321 and we add 1600, the average seasonal index for this model. We get 8908. In summer 2021, we predict 5986, in spring 6780, and in winter 7485. Here are our forecasts for the seasons of 2021. This is using an additive seasonal forecasting model. Now let's make forecasts using the multiplicative seasonal forecasting model. Whereas the additive model used the difference between the observed and the fitted value, the multiplicative seasonal index uses the ratio. We take the sales and divide it by the fitted value, 1.05. That is, in winter 2016, the sales, 7201, was 5% higher than the fitted value, 6838. Autofill this down to the other observations. In spring 2016, observed sales were only 94% of what was predicted. 6455 is 94% of this. In summer 2016, sales were 81% of what was predicted. And in fall 2016, it was 25% higher than predicted. Now we're going to take the average of every winter to modify the winter fitted value, the average of every spring to modify the spring predicted value, etc., just like we did with the additive seasonal indices. So let's look at winter and calculate the average multiplier, the average multiplicative seasonal index, the average ratio for winters. 1.05, 1.04, 1.03, 1.02, and 1.02. The average is 1.03. On average, the winter sales are 3% higher than the predicted winter sales. Autofill this down, and we get the rest of our ratios. On average, spring sales are only 93% of what we predict. Summer sales are only 81% of what we predict, and fall sales are a whopping 22% higher than we predict. Using these, we can now forecast. Since the winters are on average 3% higher, we just take the fitted value for sales and multiply it by 1.03. Add 3%, 74.95. It went up 3%. Spring sales are usually lower. Usually they're only 93%, so we multiply that by 0.93. We can, of course, autofill this, and we see that 89.66 is 22% higher than 73.21. That one went up 22% to account for the fact that all of the other fall months were also high. On average, fall was 22% higher. Now we have two forecasts for the seasons of 2021. We have an additive seasonal forecast and a multiplicative seasonal forecast. Which one do we use if we were going to report some forecasts to this small bookstore for the year 2021? I remind you that an additive forecast is better if the regression line is flat, if the pattern's being repeated but isn't moving up or down over time. Otherwise, the multiplicative forecast is better. Looking at our plot, we notice that the regression line goes up. It doesn't look like it's going up a lot right now, but if we change the axes to start at 5,000 instead of 0, we see that the trend is that the sales on average are moving up a little bit. They're moving up by 21 books per year. That's the slope of this line. Since the slope of this line is 21 and not 0, aka the line is not flat, aka on average the sales are moving upwards over the years, which by the way is fantastic news for a bookstore, we're going to use the multiplicative forecasts to make forecasts about this bookstore. And we're going to say that in 2021, they're going to sell this many books in each of the 4 seasons. 7,500 in winter, 6,800 in spring, 5,900 in summer, and 9,000 books in the fall.